Again, I will go through brief revision, will give you some tip, will revise them. So, major part of today's lecture would be on the board work. Some common points, general tips. Most of you already know it. Telling you again, nothing is going to be new today. I'm just trying to remove your confusions. Just trying to put a clear picture of this topic. You will understand this topic slowly and gradually. It needs your mathematical sense. It needs your chemical sense. It needs your common sense. All different senses you have to apply on this topic. Right? Okay. So let's begin. If I write here Na2CO3, so how many of you can recognize its name? Na is the symbol of sodium. CO3 is carbonate. So its name is sodium carbonate. Okay? I'm asking, how many sodiums can you see over here? You said just 2, because the subscript here is 2. So how many sodium right now? 2 sodiums. How many carbons? 1 carbon. No subscript, 1. How many oxygens? 3. So if I ask how many sodiums, carbon or oxygens are here, you say 2 sodiums, 1 carbon and 3 oxygen. Let's see, suppose it's written like this. Now if I ask the same question, that how many sodiums do we have here? Then here you can see a number as coefficient. Here we have 4 moles. Here we have only 1 mole. 1 is written over here. Here it is written 4. So 4 should be multiplied with these subscripts. So if I ask how many sodiums, so we will say 4 2s are 8. How many sodiums? 8 sodiums. How many carbons? You see what is the number written here? 1. So 4 1s are 4. 1 carbon. And if I ask how many oxygens do we have? 4 3s are 12. So you write that there are 12 oxygens. 4 3s are 12. So what is the main point that we have revised here? That if a number is written as a coefficient, you should have to multiply the number by the subscript to find out the number of atoms. See, another example. How many of you can name this? This is magnesium. This is phosphate. Magnesium phosphate. Magnesium phosphate. Asking you the question, how many magnesiums? 3. How many phosphorus? Phosphorus is inside the bracket. So, recalling your memories, this little subscript 2 should be multiplied with this. 2 1s are 2. So I'll write here right now, there are 3 magnesiums, 2 phosphorus, 2 fours are 8 oxygens. If the same is written like this, with the coefficient, like 3 is the coefficient. Now, how many magnesiums? 3 threes are 9. How many phosphorus? Phosphorus is inside the bracket, so this 2 is going to be multiplied, and also this 3. So what is the answer? 3 ones are 3, 3 to the 6. So there are 6 phosphorus. I repeat, phosphorus, what is the symbol? What is the number written over here? Nothing, means 1. So 3 ones are 3, and then 3 to the 6. And finally, how many oxygens? 3 4s are 12, 12 2s are 24. You should know all of these. First thing, wait a minute. Look at the board. Chemical reactions. What do you mean by the chemical reaction? Something new is forming. The product, the formulas on the other side of the arrow would be different. For example, if it's written CaCO3 plus HCl. What do you mean by the word plus over here? It means you have two things, 1 and 2. These two things are reacting with each other. This is chemical number 1. This is chemical number 2. These two are reacting here and forming something like calcium chloride. How will you know this? It will be given to you. It will be given to you. Okay? In most of the cases. Then H2O. Then carbon dioxide. So, these two are reacting together to forming this product. 1, 2, 3. What is the point that I would like to highlight here? That the left hand side and right hand side, they have different formulas. Okay? You can't expect the CaCO3 written over here. No, never. It's like a reaction. It's a chemical reaction. All right? And another clarification. Let's see an example. Suppose it's written XY arrow X2. If I ask how many X do we have on left side? 1, 2, different numbers. Here we have only 1X, here we have 2X. If I ask, just balance them. Then, suppose if I don't know chemistry, then I say, okay, it's very easy to balance them. I'll write 2 over here. Oh my, it's 2. How many x? 2. How many x? 2. If you do like this, it's a blunder. Whenever you balance an equation, never ever we can't write over here subscript. We can only write as the coefficient. We can write here. We can write here. Okay? What is the point here? To balance, if you want to write a number, never ever write a number as subscript, but we can only write in the beginning of a compound. For example, we might write like this, or here, but never over. Okay? So this is another point. So with this technical terms, let's start today's practice session. What will be doing? What will be doing today? I'll write the equation as a question, and then we'll balance it. Okay? So today's number 1 is, this is questions. This is question number 1. It's written here, HGO is decomposing into Hg plus O2. This is the question. Okay? And what is the question here? Balance this equation. If it's not. So let's see. I told you, you are not supposed to write in the question. Today I will be little simpler. I will not go in detail, but tell you verbally. Like I write here, how many mercuries? 1. How many oxygen? 1. I will avoid today this format. Then I'll ask how many mercury? 1. How many oxygens? 2. Okay? We'll ask you directly. So how many mercury? 1. How many oxygens? 1. Here we have 1. Here we have 2. I told you, do not write in the question. Rewrite the question first. So which one is unbalanced? Mercury is balanced. 1 mercury, 1 mercury. 1 oxygen, 2 oxygen. So the number of oxygens are different. On left side, on reacting side, it's 1. On right side, the product side, it's 2. So once I was teaching in the class, and I gave an equation to a student, and I said, just balance it. What he did, look at the board. He just erased it and said, sir, it's balanced. So never do like this. We can't do this. Okay, so here we have 2 oxygen, here we have 1. So how can we balance it? We write 2. We will not write 2 over here. We have just straight but over here. Now 2 oxygens. But due to this 2, mercury atoms has also changed. They have changed. Here we have 2 mercuries, here we have 1 mercury. So we'll write 2 over here. Now everything is set. 2 mercury, 2 mercury, 2 oxygen, 2 oxygen. Okay? So we write in the end, the equation, the chemical equation is balanced. See another example. Check it again. If you have any question, ask in the group afterwards. Let's suppose we have written the related question which is there in the book on page number 40, question number 29. We did most of the parts yesterday. Go through it. Now suppose acetylene phosphorus plus oxygen, and it's forming phosphorus oxide P2O5. How many of you can guess that what should we do here? One phosphorus, two phosphorus. So what should we do? Rewriting it again. Is the question that this will be given to you. So what should I do? Two phosphorus, I'll write 2 over here. Phosphorus is balanced. Okay? Here we have 5 oxygens, here we have 2 oxygens. How can we balance them? Look at the board. Use your common mathematical senses. 5 to the 10, we cross this number over here and this number over here. So 5 to the 10 oxygens, 2 5s are 10 oxygens. Oxygens, number of oxygens balanced? Yes. 5 to the 10. Repeating. See again. 2 oxygens, 5 oxygens. How can we do this? Just interchange the numbers. 5. 5 to the 10 oxygen, 2 5 to the 10 oxygens. But due to this, number of phosphorus is changed. Here we have 2 to the 4 phosphorus, here we have 2. So that's why I told you to do it with pencil until it is finalized. Once it is finalized, then you will write with the pen. So I will erase it and will write what? 4. So 4 phosphorus, 2 to the 4 phosphorus, 5 to the 10 oxygens, 10 oxygens, balanced. Okay? This one I did it yesterday. This one I did yesterday, repeating right now. How can we balance? I gave a tip yesterday. If you see consecutive numbers like 2, 3, 3, 4, 4, 5, then interchange their positions as coefficient. So 3 would be written over here. See in the answer. 3 over here, 2 over here, 3 2s are 6 oxygens, 2 3s are 6 oxygens. Magnesium plus copper sulfate forming magnesium sulfate. This will be given to you. You are not supposed to memorize it. Can any one of you point it out in here? What kind of reaction is this? Okay, let me ask this question from the beginning. What kind of reaction is this? Is it an addition reaction? Decomposition reaction? Single displacement reaction? Double displacement reaction? Combustion reaction? This one. HGO. Yes, it's a decomposition reaction. So a question is there in the book. You have to just tell that what kind of reaction is this. So if suppose it's written there and it is asked which kind, you say it's decomposition because it is decomposing over here. This and this. What kind of reaction this one? Phosphorus, oxygen, P2O5. Correct. It's an addition reaction. What is the other name of our addition reaction? Synthesis reaction, combination reaction, formation reaction. So this is formation reaction. And what kind of reaction is this? What kind of reaction is this? Magnesium is displacing, is taking off, is replacing copper. So this is single displacement reaction. Okay? Second, we have to balance it. One magnesium, one copper, one copper. Okay? Can you see now? Yes. One sulfur, one sulfur, four oxygens, Luckily, this is already balanced. The equation, the chemical equation is already balanced. No need to disturb it. So we may have the cases like this, in which the given equation would be already balanced. See another example, little bit tricky, little bit. Very famous reaction. This reaction occurs in our kitchens. Sui gas. The major part of sui gas is methane or methane. So it's the formula of methane, CH4. When you turn on the knob in a burner, CH4 or methane gas comes out. There it burns, it combines with oxygen, atmospheric oxygen, producing what? Carbon dioxide, water, plus heat. So when you a burner is using methane gas, it means carbon dioxide, water vapors will be there. So this reaction is occurring where? We can see where? In our kitchens, in burners, right? Now we have to balance it. Rewriting it again is the second last, most probably, or third last. Needs your attention. One carbon, well and good. Four hydrogens, two hydrogens. Unbalanced. What should be written over here? Four hydrogens, two hydrogens. Correct. We'll write 2 over here so that it will become 2 to the 4 hydrogen and 2 to the 4 and 4 hydrogens. Hydrogens balanced. Now see again, one carbon, 4 hydrogens, 2 to the 4 hydrogens. Oxygen, how many oxygen do we have on the left side? 2. There, 2 oxygens. So on right side, how many oxygens in all? 4 oxygens. How many oxygen on right side? 4. There, right side 4, here we have 2. So what should we do? We'll write 2 over here. Now it's balanced. Okay? KClO3. Its name is potassium chlorate. When you heat it, it will convert into it's also a decomposition reaction. Decomposition reaction. Decomposing. This one is, this one, number 5 is combustion reaction. Because oxygen is combining over here. React. Okay? Now let's check. Rewriting it again. Let me change the marker. KClO3 changing into KCl plus oxygen. Potassium chlorate. Potassium chloride. Oxygen. We want to balance it. One potassium, balanced. One chlorine, balanced. Where the problem is, here the problem. 3 oxygens, 2 oxygens. Something should be clicked over here. 3 oxygens, 2 oxygens. What is the point? Consecutive numbers. 2, 3, 3, 4, 4, 5. So then what should we do? They will be retained with interchanged positions. So 2 would be retained over here. There are different ways. This is one of the way. Excuse me. And 3 would be there. Now let's see. 2 3s are 6 oxygens. 3 2s are 6 oxygens. Fine. So let's check it finally. 2 potassium. Oh my God, it's 1 potassium. In balancing oxygen, we have disturbed potassium and chlorine. So what will we do? 2 potassium? We should write 2 over here. 2 potassium. Now check it finally. 2 potassium, 2 potassium. 2 chlorine, 2 chlorine. 2 3s are 6 oxygens. 3 2s are 6 oxygens. It's balanced. Okay? So what is the prime homework? Go through whatever we have done during the last 3 days. Alright? I may give you some homework like page number 40, question number 30, 31, 32. Intelligent ones, if you have understood these, whatever we have done during the 5, 7 or 10 days, if you have good knowledge of, then you can do question number 30, 31, 32 by yourself. If you have any question, as usual, you can ask here in the group. I'm always there to help you out. Take care. Okay?